Welcome to the presentation of our 2022 Data Mining Cup solutions. I'm Evan Callahan, and I'm joined by Gabriel de Medeiros to present the two solutions for the Grandview University teams. In our work for the project, we were joined by Gabriel Ferreira and Danny Wong, but due to internship conflicts, they were not able to join us for the presentation today. From the beginning of the competition, our objective was to identify item-specific buying patterns with the goal of predicting the duration of time until the next purchase for each user item combination in the submission set. Initially, we viewed the problem through the lens of a multi-classifier. However, the class imbalance in the dataset made it difficult to create a well-performing model. We then considered a survival analysis approach. Survival analysis is the statistical branch for analyzing the expected duration of time until an event occurs. Taking this idea, we transformed our approach to estimate the duration of time for the next purchase to occur. We then applied the scikit survival library on the available data to produce an associated risk score for each user item combination in the dataset. With these risk predictions, we identified a clear pattern between the predictions and the time to next purchase. From there, we utilized familiar regression algorithms to predict the time to next purchase using the risk scores as the contributing input variable.
Let's dive into feature engineering. Feature engineering was a crucial step in our solutions to improve the performance of our machine learning algorithms. First variable created was magic date. We had a problem to evaluate our predictions, and the magic date was very useful because it was used as a main reference point for survival model training and testing. The way it was done is we split the data on the magic date, which gives us exactly 4 weeks for our evaluation window. It simulates the February submission set used by the competition. Weeks to the magic date, number of weeks from the last date of purchase based on each customer to the defined magic date. Frequency, for each customer, how frequently they bought a product, which is measured in weeks. Average frequency is based on a product ID and basically says, on average, how frequently customers have bought a product. Neighbor frequencies, the average buying frequency of similar items using the 5, 10, 15, and 20 nearest neighbors. Target 1 is a binary categorical target variable, in which 1, it means that a product was bought in the 4-week evaluation time window, and 0 means no purchase after magic date. Target 2 is the time in weeks from the last purchase, which is recorded in the historical data set, to the latest purchase in the evaluation time window.
After the stages of feature engineering and properly restructuring the data, we considered the random survival forest model from the scikit survival library. The data was then split into training and testing sets for model building, hyperparameter tuning, and model evaluation stages. Applying the random survival forest predict method, the model produced an associated risk score for each user item combination. After graphing the results, we could see a strong relationship between risk scores and the time to next purchase. To build upon the risk score predictions, we transformed the problem into a regression task. Utilizing the random forest regressor and XGBoost regressor libraries, we used the user item risk scores to estimate the time in weeks until the next purchase. Again, we went through the processes of splitting the data for the model building, hyperparameter tuning, and evaluation stages before returning the highest performing model for each of the regression frameworks. Finally, we added the estimated time in weeks to the most recent purchase date for each customer combination to derive the February replenishment labels needed for the submission dataset. So here we visualize the predicted risk scores and the actual time to next purchase in weeks. And from this, we can see that the survival model is doing a good job at distinguishing between whether or not an event would occur, and we see a higher risk scores indicating that it would be the item would be purchased in a lower amount of time. From the estimated time to purchase, we derive the February replenishment labels required for the competition submission set. And compared to the initial multi-classification approach, we saw a significant increase in the number of predicted purchases for the month of February. And upon analyzing a select number of predictions, the results of the regression model seem to follow the similar buying patterns shown in the 7-month-long training period for several of the combinations. Our first team solution used the random forest regression model, while our second team solution used an XGBoost regression model, where we saw slight variations between this two sets of predictions. We wanted to say a quick thank you to the Data Mining Cup competition organizers and all participating teams. We are looking forward to competing again in the future.